Hey everybody, welcome to Zeros of Polynomials. Today we're going to look at finding zeros from graphs, factors, and quadratics. And some of the stuff that you guys see here on the opening screen is what we're going to be going over, right? So down here we have a quadratic, so we're going to figure out how to extract the zeros from that. Up here we have a polynomial in factored form. We'll figure out how to get the zeros from that. And then over here we have a graph, and we will also work on finding the zeros if all we have is the graphical form. So why do we want to do this? Why do we care? So what this does, finding the zeros is going to help us solve polynomial equations, which is going to come in handy when we get to applications, right? When we do an application, we lift it into an equation, and then we have to solve it. Well, finding zeros is basically how we solve these higher order polynomial equations, so it's going to help with that. It helps us find the x-intercepts of graphs. So if we're given a polynomial in the equation form only, we will be able to find the x-intercepts of the graphs if we can find the zeros. It helps us sketch graphs because, again, we can find the x-intercepts. And when we get to multiplicity, that will also help us sketch these graphs of polynomials. And in applications, finding the zeros will let us know when things shift from positive to negative or from negative to positive, right? Because crossing over a zero means you shift your sign. So they help with that. And I have down here, they help with all kinds of applications in calculus. So when you get on to the next level, these will become very applicable. So finding zeros from graphs. So if we have a graph, and I'm going to take us over to Desmos. So we have a graph, and suppose we have this graph, and let me zoom out a little bit. So all you're given is this picture, and what you have to try to figure out is like, okay, well, what's the zero, and this is all you have. So what is it that we're looking for? What is the feature of this graph that would give us the zeros? Well, what we're looking for here is we are looking for the x-intercepts. So here's one here, and here's one here. So the zeros then of this polynomial, if all we are given is this graphical representation. So here's an intercept at 2. Here's an intercept at -3. And this does have a higher multiplicity than 1, which we will get to later. But for now, we would say the zeros are at -3, and the zeros are at +2. Okay, so when you're trying to find zeros from a graph, look for the x-intercepts, and it's the actual number for the intercept that you're looking for, and that's your zero. So let's trash that. Let's look at a different example. And if you see, that was the equation that we were looking at there. Notice my zero was at -3 and my zero was at +2, so kind of start seeing a pattern there. Now let's look at our second graph. And let me zoom in just a little bit. So hopefully you recognize this as a parabola. It's a graph of a quadratic. And let's see what our zeros here would be. So what are we looking for again if we're trying to find zeros of a graph? Well, we're looking for the x-intercepts. So I have two x-intercepts here visible to me, and it's a quadratic, so I do have two zeros in this case. And it looks like one of my zeros is at 0, and one of my zeros is at 1.667, which has a fractional representation. So it looks like I have a 0 at 0, and 1.667 is 1 2/3. This is better known as 5/3. So those would be the zero of my quadratic. So again, what are we looking for here? We are looking for the x-intercepts. So when you're trying to find zeros from a graph, look for the x-intercepts. So let's head back over. So that was zeros from graphs. Now what about zeros from factors? So I have a polynomial here, both here in factored form. How do I find the zeros? Well, the concept that we're going to look at here is we say if x minus c is a factor, that implies that c is a 0. So what does that mean for us? So that means here that if x plus 3 is a factor, that means then that x equals positive 3 is a 0. Here, if x minus 2 is a factor, that means x equals positive 2 is a 0. And here, and this x equals 2 also has a multiplicity of 2, again something we will get in later. Our last factor, if x plus 4 is a factor, that means x equals negative 4 is a 0. So my zeros of this polynomial here would be 3, 2, and negative 4. Okay, heading over to this polynomial here. So this 5, and this gets a lot of people, we don't care about this because this 5 is not in the form of this x minus c. So think x minus c or x plus c. And let me even simplify this more. If x plus c is a factor, that implies then that x equals negative c is a 0. So this 5 all by itself is not written as x plus or minus something, so therefore we actually are going to discard it. So if you see a number on the outside, that is not applicable to your zeros, okay, so we can just ignore it. So if y minus 1/2 is a factor, then y equals positive 1/2 is a 0, and if y plus 3 is a factor, then y equals negative 3 is a 0. So in this polynomial here, our zeros would be 1/2 and negative 3. So good rule of thumb, it doesn't work always, but just think the opposite. If you have a factor, then the opposite is going to be your 0. So now, if we know how to find a 0 from a graph, and we know how to find a 0 from a factor, then what about if we have an equation of a quadratic written? So this is not in factored form. This is also not graph. Not to say you couldn't graph this and find the x-intercepts and get the zeros. That would be a very clever way to solve either one of these. But let's suppose we don't have any graphing software at our disposal. So how would we get the zeros here? Well, what do we know? We know how to get zeros from factors. So is there a way to get from this quadratic into its factors? In other words, can we factor it? And that's exactly what we need to do. So we have 0 equals, the lead coefficient here is a 1, so our factors are going to work out really nicely. We don't even need to launch in a box method or anything. So we're going to have an x, we're going to have an x, and then our back two numbers here. We need two numbers that multiply to negative 4 that add to positive 3. So we're going to use positive 4 and negative 1, right? Because negative 1 times positive 4 will give us the negative 4, and positive 4 minus 1 gives us the positive 3 here. So here are our factors. So now from factors we can go to zeros, right? So if x plus 4 is a factor, then x equals negative 4 is a 0. And if x minus 1 is a factor, then x equals positive 1 is a 0. So there's our zeros there. So same thing for this problem, factor it. Now this is not a trinomial, so we're not going to factor it that way. However, what do we have here? We have a 6x squared and a 2x, so they both contain a common factor of x. So let's use greatest common factor. They also contain a 2, right? So the greatest common factor here is actually going to be a 2x. So let's pull that out in front. If I pull 2x out of 6x squared, that'll leave me with 3x. And if I pull a 2x out of negative 2x, that'll leave me with a negative 1. So now this is factored. What do I do with this 2x? So this 2x is a factor. So what is my 0? Well, in this case, my 0 would be 0. So what we're actually looking at is we're looking at, okay, well, what if I have 2x equals 0? What if I have 3x minus 1 equals 0? And we're solving these two out. So if 2x equals 0, then x would equal 0 here. You can think divide by 2, divide by 2. And if 3x minus 1 equals 0, add 1 to both sides, divide by 3. Our other 0 would be at x equals 1/3. So here's 1, 0, and here's the other 0. So another way, if you can't just go straight from, oh, this is a factor, so or this is a factor, so this is a 0, what you do is you set up two little mini equations. So right here what we did is 2x equals 0, and right here 3x minus 1 equals 0. So again, because we know each one of these factors are zeros, that's why we set it equal to 0. And then we solve it out, and we get our two zeros here. So as a wrap-up, let me find a better color. As a wrap-up, so this whole video was kind of explain how zeros, factors, and x-intercepts all relate, right? So if I have a 0 of 5, how does that relate? That implies then that my factor would be x minus 5, which would imply that my x-intercept of my polynomial would be at 5, 0. Okay, well, what if I knew that I had a factor of x plus 2? Okay, well, that would imply then that I have a 0 at -2, and it would imply that I have an x-intercept at -2, 0. Okay, well, what if I only knew my x-intercepts? Okay, well, what if I knew I had an x-intercept at 1, 0? Well, that would mean then that my factor is x minus 1, and that would mean my 0 is x equal 1. Okay, so if you can get one of these things, you can generate the other two, and that's the point of this slide. If you know the intercepts, in other words, you can graph your polynomial, or you have a graph of your polynomial, you can get your intercepts, which will get you your factors, which will get you your zeros. Or if you have an equation, you can get it in factored form, which would get you your zeros, which would also get you your x-intercepts. Or suppose all you have are zeros and you have to generate everything else. Well, you can go from zeros to factors to x-intercepts, right? So for our last example, what if your zeros are 3 and 5? Well, that would mean that my factors are x minus 3 and x minus 5, which would mean that my x-intercepts are at 3, 0 and 5, 0. Okay? So just so you see, all of these things are related, and there's many, many different ways to find zeros. You can graph it, you can factor it, okay? And those are the main two that we're going to be working with right now. In the next video, we'll look at finding zeros of polynomials of order 3 and greater. And for those, we're going to use a little bit of synthetic division. So I hope you guys enjoyed this video, and as always, if you guys have questions, please don't hesitate to ask.